Let's talk about quadratic function, or everything we need to know about the parabolas and how to do factoring. What's a quadratic function? Well, quadratic function is a function made out of a trinomial, like, for example, this one right here. We already seen a quadratic a polynomial made by discrete algebraic expression prior. When these are involved with a function, they will express a parabola. The parabola is this type of figure made in our xy plane. The parabola itself and the quadratic function itself has some characteristics. One of the first characteristics, and I'll go back to drawing, is that you either have a lowest point and is high, or a highest point, a minimum point or a maximum point. That one will be determined by the vertex. The vertex is the point where the parabola reach its lowest point or its highest point, like in this case. How can we determine if a parabola has a minimum vertex or a maximum vertex without drawing? In that case, it will be determined by the value of a. In this case, this one right here. If a is greater than 0, meaning is positive, we will have a minimum point, like in this case. If a has a value of less than 0, meaning negative, we are going to have a maximum point, which is this case, the case in the right drawing. Another important figure that we need to recognize from the vertex is axis of symmetry. Its axis of symmetry is this line right here, the start from where is the vertex point. That axis of symmetry is a sort of a bisect. Bisect is any line or segment that will split your figure into exact parts. So the vertex will divide your parabola into exact half. Another important figure that we need to recognize on the parabola are the x-intercept. What are the x-intercept? The x-intercept of a parabola usually are 2 and are to the point passing through the x-axis. Now that we have recognized all the main points regarding a parabola, we need also to discuss 2 other type of formula for quadratic function. In fact, all these parabola talking that we did it out of the standard form of our parabola. This is the standard form that, again, we have been knowing since before. But when we talk about parabola, there are other 2 functions that we can run into. Another type of formula could be given in this form. In this form, fx equal a, then multiply x minus h to the power of 2 plus k, has the characteristic of having a special product. And I hope you remember what's a special product have. But also, he has two constants, which are h and k. H and k are the coordinate of our vertex. So it's important when we write the vertex form to know the vertex coordinate. We will see later how we can find the vertex form starting from the standard form. Another type of form of the function that we can find is the factor form. The factor form is in this format, so it's written as a binomial, ax minus b, then multiply x minus c, that will provide to you the x-intercept of your parabola, where b and c are the x-intercepts. So from those formulas, we can draw a parabola like those two. So let's try it out. Let's try out to make a drawing out of this function that we have here. Here we have a function is fx equal x to the power 2 plus 2x minus 2. But first, before drawing it, let's answer these 4 questions. In question letter A, they are asking us to find the y-intercept. As for the equation, whenever we want to find the y-intercept of something, we need to plug in the x value. And since we are looking for the y-intercept, meaning the point that is in one of these points in the line, in that case, my x, so for A, my x will be equal to 0. So if x is equal to 0, when I plug it in on my function, I will have 0 to the power 2 plus 2 to multiply 0 minus 2. So my y-intercept will have y point that is -2. So the coordinate of all these will be just 0, -2. So in our possible drawing here, my y-intercept on the graph will be right here. The second question, question letter B, is asking for the axis of symmetry. To find the axis of symmetry, we actually have a formula, and the formula will be this one right here. X equal minus B over 2A out of this standard formula. So let's just plug it in. So to find my axis of symmetry, I need to apply the formula minus B over 2A. In this case, B is equal to 2. So negative B will be just -2 over 1. Over 2, sorry. So my final answer will be that the axis of symmetry start at -1. So it will be here. That's where it's gonna be my axis of symmetry. That's where my vertex is gonna land. In fact, fun information, and actually very important, the value of the axis of symmetry will be always also the h coordinate of your vertex, meaning the x coordinate of your vertex. Okay, let's go and answer C. C is asking the coordinate of the vertex. So following up what we just said, that finding the axis of symmetry will give us also the x coordinate of the vertex. Now we need to find the k component of the vertex, meaning the y value. What do we do in this case? Again, as we were doing for the equation, whenever you want to find the value for y, we just apply the value of x. And in this case, the value of x is -1. So I'm going to take my function and I'm going to look for f of -1. This one will determine my value for k. So now that I determined that one, it's going to be -1 to the power 2 plus 2 to multiply -1 minus 2. -1 to the power 2 will be just 1 minus 2 minus 2. So this will be equal to -3. So the coordinates of my vertex will be -1, -3. So this one will be right here at this point. Letter D is asking to find out if the vertex has a maximum or a minimum. To determine this one, we just need to look at my value for A, and A right now it's equal to 1. Since A is equal to 1, that means that A is greater than 0. Since A is greater than 0, that means that we are going to have a minimum point. Now, to finish and be able to make the drawing of this equation, we need to find also our x-intercept, right? How can we find our x-intercept? Is by using factorization. So let's see how to find those two x-intercepts. To do so, we will use a quadratic formula, and I'll show it to you in 1 second. To finish our drawing, we need to use the quadratic formula. So we need to start talking about factorization. Before going toward all the factorization, let's do this first step, which is finding the x-intercept of our quadratic formula. So in this case, we already start from this function. We already found our vertex, our y-intercept. Now we need to find the x-intercept. To find the x-intercept of a trinomial like this, we just need to use this formula. This is called a quadratic formula, where in a polynomial like ax to the power 2 plus bx plus c, we put it equal to 0, we can determine our x. In our case, we can put it equal to 0 because since we are looking for the x-intercept, my fx is going to be equal to 0. Both cases are going to be equal to 0. So what we do, we just apply the formula. For our function, b will be equal to 2. So we are going to write -2 plus or minus square root of b to the power 2 will be just 4 minus 4, then multiply a. In our case, a is just equal to 1. Then multiply c. In our case, is -2. So it's not going to be negative here, but it's going to be positive. And here is going to be 4 multiplied by 2, which is 8, over 2a. Since a is equal to 1, it's just 2. Whatever is inside the parentheses will be 4 plus 8, which is 12. 12 square root of 12. We need to have a lot of fantasy here. Is going to be 12 can be factorized as 6. Okay, perfect. So it's gonna be 2 by 2 by 3, right? So that means that the 2 is out of the square root, but 3 stays still in the square root. So square root of 12 is gonna be 2 square root of 3. So what are my x's? x1 will be -2 square root of 3 over 2, and x2 is gonna be -2 minus plus 2 square root of 3 over 2. So let's use our calculators, and we will find that This is going to be 4.8. And this is going to be just square root of 3. I'm sorry, it's not 4.8. This is 2.4. And that's going to be negative. And that's going to be 0.9. Okay, so they were a pain in the neck, but we got our x-intercept. Our x-intercept are going to be around negative 2.4, which is, I would say, here, and 0.9, which I would say is around here. So now with a red pen, we're just going to draw our parabola. That's going to look something like this. Okay. Okay, now let's talk about how to go from the standard form to the vertex form. The proceeding is pretty simple. Here the question is asking basically this. Which of the following is an equivalent form of the equation of the graph shown above, from which the coordinate of the vertex P can be identified as constant in the equation? First of all, we need to remember how the vertex form looks like, and the vertex form looks like this: f of x equal a, then multiply x minus h to the power 2 plus k. So out of this formula, what we need to find are my vertex coordinate h and k. We already saw before how to find them, so let's do it again. We have this formula right here. To find my value of h, I'm going to use my axis of symmetry. The formula for my axis of symmetry is negative b over 2a. And my b in this case is negative 6. So negative by negative is going to be 6. And my a is equal to 1. So my h will be equal to 3. What's going to be my k? To find the value of k, as we did before, we just need to plug in my x value on my original formula. So it will be 3 to the power 2 minus 6 to the power 3 to multiply by 3 plus 5. 3 to the power 2 will be 9. 9 minus 18 plus 5. So k will be equal 9 minus 18 is minus 9 plus 5, negative 4. So the two h and k are going to be h3 and k negative 4. How do we write it back to the equation? It's going to be f of x equal, my a here, it's equal to 1, so nothing. X minus 3, so opposite sign here, to the power 2 plus actually minus 4. So my answer will be D. And in this specific question, we would give right away the answer D because it's the only one in the vertex form. Okay, so in that case, you didn't even need to find it itself. What about the standard form to the factor form? We just saw the quadratic, how to use the quadratic formula. So I'm gonna go very quick. Here we have the same formula and we need to apply the quadratic formula to find the binomial that will determine the factor form. So if which of the following is an equivalent form of the equation of the graph shown above that display x-intercept of the parabola as constant. So we know that we need to use the quadratic formula, so let's use it. My b, we say, is -6, so it's going to become just 6 plus or minus square root of b to the power of 2 is going to be 36 minus 4, then multiply 1, then multiply 5, all right, over 2a. A is equal to 1, so just 2. Let's focus right now what's inside the square root. 4 multiplied by 5 is 20. So what we have inside the square root is going to be 36 minus 20, meaning 16. So 6 plus or minus square root of 16 over 2. I already can talk about the two possible answers, x1 and x2, sub 2. Why? Because 6 square root of 16 is going to be just 4. It's not going to be like the case of before. This is a straight up whole number, an integers. So in the first case, I'm going to have 6 plus 4, which is 10 over 2, or better say 5. In the second case, I have 6 minus 4, which is 2 over 2, which is 1. Now that I find my two x's, what I need to do is just plug it in inside the factor 4. And when I plug them in, what I do is inverting the sign. And you should remember that one for when we talked about remainder theorem. So I'm going to have x minus 5, then multiply x minus 1. So our possible answer is A. C and D were not countable. We could have answered just between A and B, and we will answer A for the fact that we will switch the sign. Important. There is another method, which is the boxing method. The boxing method is an important method. It's the method we will use every time we want to just find out the binomial, and when we deal with a value of a greater than 1. Not that the quadratic formula is not good for that case, but the quadratic formula gives you right away the x-axis. But if you want the binomial and there is a value of a, using the boxing method will give you right away the answer that you need. So what's the boxing method? The boxing method is involves a box like this one, where we are going to write the value of a here, the value of b here, the value of c here, and the value of b here. We will look at two numbers that multiply to each other gives you a, and multiply to each other gives you c. Then we will cross multiply those values, and the result of this cross multiplication will be written here and here. If the addition of these two numbers will give you the result of b, then the order that you put the information is correct. Now, let's see what we're talking about. Let's talk about this polynomial. We need to find the binomial of this one. So what's my value for a? 3. What's my value for c? -49. What's my value for b? 14. What are two numbers that multiply to each other gives you 3? Since 3 is a prime number, there are only two numbers that will give you 3, that are 3 and 1. When we get to 49, in this case -49, there is a method to find all the possible numbers that multiply to each other gives you the number. That is prime factorization. I hope you remember it. In this case, 49 is actually a very nice case, because if you prime factorize it, the only two numbers that will give you 49 are 7 and 7. That's it. But we have negative 49, so we need to choose which one is going to be the negative one. For example, if I choose that this one is the negative, now I do the cross multiplication. 3 multiplied by negative 7 will give us negative 21. 1 that multiplies 7 will give us 7. Negative 21 plus 7 won't give us 14, but it will give us negative 14. So this order of information is incorrect. What do we do here is just switching some information. In this case, the one that we need to switch is just the negative. We'll put the negative on top. And now we have negative 7 here and plus 49 on the bottom. Plus 21, sorry, in the bottom. 21 plus 7 will give you 14. So my order is right. Now, how do I write our binomial? That's even simpler because the binomials are already here. That's the first binomial, and this is the other binomial. What we need to do is just including x in the value where there was a involved, so in this column. So my final answer for this trinomial in the binomial form with the boxing method is 3x minus 7, then multiply x plus 7. If you want to prove it, you do the distribution with the method that we learned, which is the FOIL method, and you'll see that your final answer will be again this trinomial. There is even a third method, which I want to talk to you. I haven't talked to you about it during our lessons, but it's pretty straightforward, which is finding the integers that you need to do the binomial. That means that sometimes you can do this process in your mind, because to factor a trinomial, what you need is just the value that's by two values that sum together give you the b, but multiply together gives you the c. That's what we are looking for, and here there is the explanation for it. So let's try to think about it. Let's do question. Let's do the binomial, the trinomial that is right here, x to the power of 2 plus 9x plus 20. Again, we need to find those two numbers. The sum together give you 9 and multiply together give you 20. 20 is a number that can be found by multiplying what? 5 by 4, for example, or 10 by 2. Now, if I add 10 plus 2, I don't get 9. But if I add 5 plus 4, I get 9. So I already know that the binomial that come up from this trinomial will be x plus 5 and multiply x plus 4. That's it. You want the proof? Let's do FOIL method to see it. So x, the multiply x will be x to the power of 2. X, the multiply 4 will be 4x. 5, the multiply x will be 5x. 5, the multiply 4 will be 20. You sum these two numbers together and you get back x to the power 2 plus 9x plus 20. That's it. That's the method you might want to use when the trinomial is simple enough, like in this case. Let's take a look at the second one. X to the power 2 plus 5x minus 14. Here there is a minus involved. So we need to find those two numbers that add together gives you 5, but multiply together gives you negative 14. And since you see that c is negative, you know that one of these two numbers needs to be negative. That means that here on b, we don't have an addition anymore, but we most probably have a subtraction between the two. If we look at 14, just 14, we know that 14 can be get by doing 7 by 2. Or that's it, just 7 by 2. We have nothing else. I know that one of these two numbers, though, needs to be negative, so that is negative 14. So I know also that the two numbers are going to be added to each other. Which number of the two needs to be negative so that you end up with this addition to have 5? It's going to be 2, right? That's it. And now your binomial, you know that your binomial will look like this: x plus 7 and multiply x minus 2. One, you can do your proving. It's by x to the power 2. X by negative 2 is going to be negative 2x. 7 by x is going to be plus 7x. And last one, 7 by negative 2 is going to be negative 14. You do the sum and get x to the power 2 plus 5x minus 14. That's it. That's pretty good. I'm not saying that it's that easy to use it, but sometimes can be that simple. Can be that rewarding to finish like that, you know, to not needing to do anything else. Well, this video has been already too long. Let's talk quickly about the discriminant. The discriminant, it's an information that some SAT question can ask you, and it is related to how many roots, how many zero, how many x-intercept you can have. So when you find your discriminant, what you calculate is whatever is inside the square root of your quadratic formula. That's what you do. If the result that is inside here is positive, then you know that you're going to have 2 x-intercept. If the result that is inside that square root is going to be 0, you know you're going to have 1 x-intercept. If it is negative, when you have square root of a negative number, you have no real solution, so are going to be 0. And those are the cases. Okay. And lastly, let's solve this one. The reason why I want to solve this one, because here we solved these many types of polynomials or trinomials in different ways. But sometimes for the SAT, you need to just work smarter. On question number 11, we have this trinomial, and then the question says, the equation above represents a parabola in the xy plane. Which of the following is equivalent form of the equation displays the x-intercept of a parabola as constant or coefficient? If we have paid attention so far, we know that the only two possible answers are either A or B, because C or D are vertex form. So the answer is either A or B. Since this question this question has a 50-50% 50-50 chance that you get the answer right, instead of going ahead and solve these trinomial by using the boxing method or whichever method you want, why don't we just do the multiplication of the binomial? We choose one, and if that one is correct, that's great. If that one is wrong, then the other one is going to be the correct one. So I'm going to take A, and I'm going to use the FOIL method. So I'm going to have 2x to the power of 2 plus 4x minus 3x minus 6. I hope you follow me here. So what I get is 2x to the power of 2 plus x minus 6. That's the trinomial that I will get by having this binomial right here. Is this one the trinomial that was here at the starting point? No. So A is not even the answer. My only answer is B. Solving this question by looking at the answer and going by using the multiplication, the FOIL method, it's way easier. Okay. I'm gonna leave you some homework, 1 and 2. I'm gonna leave it for you on the PDF I'm gonna send you about it. And let's talk later on. Good luck. Bye.